All right, guys, welcome to Unit 5, Backup and Disaster Recovery for Virtualized Systems and Platform Services. Well, before I even dive into this, let me say this. You guys are in the home stretch. Next week is week 6, which means the last of this unit, uh, last of this class, and the final. So if you're wondering what the final's going to cover, it'll be Unit 5 and 6, and it'll probably be 30 questions, not 25. I'll probably make it 200 to 250 to 300 points. Still working on it, but it's just, letting you know ahead of time. What else can I think of? Also, if you're watching this on Sunday, which I hope you're watching it early and not late, everything, if you haven't turned everything in yet up to this point, turn it in by Friday of this week, which will be, I'm checking the date, the 8th of December. I'll also make a announcement about it, probably Sunday or Monday when I get the chance, if I remember. Please turn everything in if you haven't turned anything in yet. Turn it in to the 8th. Anything after the 8th, I won't accept anything but Unit 6. That's it. So just letting you know now before it's too late. Okay, guys. So let's dive into Unit 5, the first part of Unit 5 here. We're going to talk about backup strategies for VMs and platform services. So this is going to deal a little bit more with, I'm going to put this, a little bit more with an overall strategy, not just specifically for VMs or platform services, because they're kind of go in tandem, because you back up in the sense of, is it on-site, off-site, things like that. They all apply to these and regular on-site machines and the way you go about it. Avoid that from my antivirus here. I'm sorry about that. I'm going to talk about disaster recovery planning and testing. Remember, I do the testing part. The testing part you do once every 6 months. That's how I can tell you about that. Virtual machine and platform service backup solutions. I do talk about that. Then high availability and virtualization and platform services. Like, what does that mean? What does it cover? So that's what we're covering in this. It's about 40 slides, give or take. So let's dive right in here. So what is a backup? At this point in the stage of this class, I think you would know what a backup is. If you don't, that's okay. A backup refers to the copying of physical or virtual files or databases to a secondary location for preservation in case of equipment failure or catastrophe. So, if you're at home, you back everything up to an external drive, that's a backup. You do an image capture through Acronis True Image or any other software that can do imaging, like Windows Restore Point. I believe you can do Windows Shadow Copy now in Windows 11, I believe. You might want to look into it if you're curious. Um, that's what that's covering. But how is it different from what's called a backup strategy? Well, they both have backup in the name, right? But one's the actual act of making it. The backup strategy is a comprehensive plan of action that many businesses, I can't roll my E's and S's today, I guess, follow to protect against data loss, incidents, and quickly recover with minimal or no damage to workflow or reputation. So let's say, you've probably seen it or experienced it if you have a Facebook or YouTube account, or even you watch YouTube or Reddit. And just think of the three, they're popular in general. When they go down, how big of a stink is it from them? Hearing like, hey, Facebook's down. Hey, Reddit's down. I can't get to my Reddit sub. Blah 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 blah. Or I can't access YouTube down. You hear about it like nonstop practically until it's fixed, and that's a ding to their reputation. So that's kind of what that's referencing. So let's talk about why we back up data. What's the point? The purpose of the backup is to create a copy of data that can be recovered in the event of primary data failure. So if you back up, say, your Windows machine or Mac, whichever one you use, and you backed everything up and the hard drive dies tomorrow for some weird reason, cool. You still have all your files saved somewhere else. You're okay. Primary data failures can be the result of hardware or software failure, data corruption, or human-caused event, such as a malicious attack, virus, or malware, or accidental deletion of data. Backup copies allow data to be restored from an earlier point in time to help the business recover from an unplanned event. Also, the other thing about human-caused events that people didn't mention in this definition was you sometimes pull the power cable back there, hit the power button by accident, and just nuke it off the face of the planet. That might be enough to cause a short. So let's get into the differences, because there's a couple different kinds of backups here I'm going to mention in brief here. So one's backup versus archive here. Backup is a copy of your data, right? Whereas an archive is a historical copy that you keep for the retention purposes, often for long periods. Archives are typically used to save old and active data for compliance reasons. Like HIPAA compliance, privacy compliance. If you worked at a hospital, they have to keep your files on record for a while. I think minimum is 5 years, so that will go into an archive. Where backup versus a sync here. Sometimes people confuse the word backup with sync. These are not the same thing. A backup is a copy of your data you can use to restore lost files. Syncing is the automatic updating and merging of two file sources. Cloud computers often use syncing to keep files in one location identical to files in another. So for example, I use Google Drive to save all these slides after I make a mirror on my PC and I sync it. After I upload it, just every edit I do, it syncs up to the cloud, so it's done. I don't do anything, different from there. But an example also I have here of a backup is when your mobile phone backs up to the cloud. And if your factory reset the phone, you restore your application settings data from the backup copy. An example of an archive, it's a tape backup in old HR files. So I was talking about the hospital that have long since been deleted from the server. So that's just examples I have here in notes. Don't worry, I'm not going to ask you these specific examples in the final probably. So how often should you back up your data? Personally, I only back up my files that are like my resume, like transcript copies, letters of recommendation, templates for stuff. Those are the only real things I back up, and maybe like pictures of my wife and I from our wedding and our trips. That's all I really have backed up in my cloud personally. That's as far as I'm going to share in that. But like movies, games, and all that, if my computer melted, whatever. I'd probably cry because I lose all my music because I have like 20 years of music. Back in then we had CDs. I would rip all my CDs. So that took like a week and a half when I first did that. And I kept that catalogs, which I've had to this day, thankfully, because I migrate to like different drives as I build PCs and just transfer stuff over, and I haven't lost it. But maybe that's something I have to consider back. And I'm just talking about personal sense, so you get an idea of how do you should back up. But here you go. Let's get into this. I'm just segueing so I can give some personal context to the thing. And I'm talking with my hand because my hand's put away because I'm cold. So should you run full backups regularly or rely on incremental backups? The answer is both have their place. To fully protect yourself, perform regular full backups and keep them safe. Keeping them safe is essential. Full backups can be scheduled for slow times or performed overnight when no one is using the data. Remember that full backups take the longest to complete and are the costliest, but the easiest to restore. Personally at work, we do full backups every 3 months over a weekend. And then we do incrementals every week, starting from Friday to Sundays, because no one's logged into their machines. That's why. So a full backup backs up the entire server. An incremental backup only backs up files that have changed or been added since the last backup, saving storage space. The cadence of full versus incremental, I got the word right? Isn't that nice? Backups might look different from each organization. How will you monitor your backup? It's not just enough to schedule. It's not enough to just schedule your backups and walk away. You need to monitor them to ensure they are occurring on schedule. You should also test your ability to restore and fully understand the options you have for restoring your data. A backup is only as good as its ability to restore. You must test this out periodically to ensure you have a solid disaster recovery plan in place. So disaster recovery plans usually get tested twice a year or every quarter. So that's 4 times a year, depending on your organization. We do it every 6 months just to be on the safe side. The latest backup we have is from 2 months ago. Let's slap it in a virtual machine and make sure it comes up. And once it comes up, we make a virtualized network. We make a small copy of our domain in that sense and launch it through all virtual software, obviously with the machine join and just test logins randomly. And, did it restore user, test user with data? Yeah, okay, cool. We're done. That's how we normally do it. Other places do it every 6 months, once a year, because it's expensive to have a lot of people do this, believe it or not, because it's taking time out of your workday, or it's a project you run over the course of like a month or two. It really depends. So let's talk about how long you should keep your previous backups. You also must consider how long you want to keep your previous backups. Will you keep them for a specific amount of time and overwrite older copies? By overwriting the files, you can save space, but you may not have an old enough backup when you need it. So an example of that, actually, for backing up, and this is for one department for admissions. I guarantee you, psychology has the same issue. They have to deal with legal requests too for like transcripts and things like that. And that's because people are in trouble or going to jail, but sometimes they need to verify something, right, legally. So they have to keep a big record of, probably I think it goes back to the 80s now. They have digital. Anything after that's still paper that you can request. It's sent up. I forgot how they did it, but now it's on microfilm too. So a microfilm, if you're curious, look it up. It's a set of just a spool of film, and it's like this big, but it holds all the data. It's like the size of like that big, and they use a microscope to read it and blow it up and print it out. That's what they've been using for a while now, but I think they're going to be moving away from that soon to digital too, for us where I work at. But that's just an example, because the stuff, people from 40 years ago now, which is like the 80s, right? They still need their transcripts if they're applying for work and they request them. Well, they have to have a copy on hand. So that's where they keep it. Also keep in mind that many cloud storage vendors have minimum retention policies for deleting file or deleted files. If retention sounds like a good thing, in this case it's not. They might be charging you for data storage for 30, 60, or even 90 days, even if you delete it after storing it for just one day. That may also factor into your decision about how long you should keep your previous data files or backup files. Some experts recommend 3 months, but that may not be enough in some situations. It all depends on where you work and what part of the industries you're working or career fields. I mean, you still be IT, you can be IT for the government, IT for public, IT for private. They all vary in terms of backing up and how long to keep them. So I can't really definitively say how long the Pentagon keeps their stuff or anything, but I'm sure. I'm thinking like, I don't know how Microsoft does, private entities, Google, things like that. They're all different based on where you work and what industry it's in. You need to keep full backups for as long as you might need to recover from various issues. If, for example, you're infiltrated by a cyber criminal and don't discover it for 2 months, will your oldest backup be enough to restore your system back to a clean slate? Another question to think about is if you'll keep an archive. As a refresher, an archive is a backup of historical data that you keep long term, even if the files have already been deleted from the server. Most sources say you should plan to keep archives forever, unless you have no use for the data in the future. But your company might have a different appetite for retention. That's a really wasteful appetite for retention time frame. Forever probably seems like, well, a long time, but keep in mind that the security of having those files available may be worth it. Moving on. Special considerations for backing up. When backing up servers with different operating systems, you need to consider the constraints of that system. For example, SQL servers can handle differential backups, whereas other servers cannot. Some backup software like Veeam, cloud-based backup, integrates easily with all the major operating systems and therefore supports backups of multiple servers using different platforms. If you are backing up a single server, things are easy. One server is not hard to back up. But if you have a whole warehouse of like 50 servers, it's a big undertaking. You have only one OS to worry about. However, if you're backing up multiple servers with different platforms and applications running on them, things could get more complex. Be sure to research all your options and use a vendor that can easily handle groups, group management, and SaaS, managed software as a service, backup services, so that you can view all your data through a single pane of glass. It means you can all view it like one item, not like multiple reports and all that. You want consolidation and easy delineation if you need to pinpoint a single system to restore. You can use groups to easily manage different servers with similar operating systems to keep things organized and streamline your backup strategy. So let's talk about destinations. Give me 1 second while I get a cup of water. All right, so backup destinations. When selecting a backup destination, you have many mediums to choose from. There are pros and cons for each type. Some popular backup destinations and their pros and cons are as follows. So we have external media, USB, which is still around. CD, not so much. Removable hard drives, yes. Flash drives, yes. Now you can include SSDs in that. Quick and easy and affordable, but it's fragile if dropped, crushed, or exposed to magnets. Very small capacity. The magnet part refers more to the spinning hard drive than anything else. I don't know if flash drives can be affected by those. Maybe, depending if they rip out the tracing, I guess. Network attached storage, NAS, always available on the network, small size, and great for small server message blocks, SMBs. Protocol is a network file share protocol. Vulnerable to on-premise threats and non-scalable due to limits. So that's a limitation. Network or SANs, storage area network storage. High speed, you connect to drives as local, good security, failover protection, excellent disk utilization, and high-end disaster recovery options. Can be expensive though, doesn't work with all types of servers, and is vulnerable to attacks on the network. Give or take. And probably one of the oldest forms here for backup is tape. Dependable, robust, not fragile. Can be kept for years, low cost, and simple to replicate. So tape drives, I'll show you what they look like. I'm sure some of you are like, what's a tape? What's a tape drive? Let me pull it up. Tape drive. Hold on. I gotta word this correctly. So it pops it up, right? I mean, these are all. Yeah, that seems about right. Here we go. Let me pull it over. That's what they look like in series, and this is what they are like. And here it is when you pop it into the, that's a Dell server. I can tell you just by looking at it. That's where they pop it in, and that's what they look like. So if you're curious, that's what they are. It's old. It's been around, I think, since not even the 80s, before the 80s. I think late to mid 70s when they came out. So cons is it's highly initial setup costs is expensive. Limited scalability, that's true, but they can hold a stupid amount of data, I think, per tape now. Potential media corruption over time and time consuming to manage. The media corruption, yeah, but it's Jesus, how long does tape last? I mean, technically, tape can last more than 30 years, from what I remember off the top of my head. But it's getting harder and harder not to find tape manufacturers, people that know how to work the tape system. Because I mean, let's face it, tape is getting phased out at this point because everything's going cloud or flash based. But with flash based, you guys know after it reads and writes too much, it burns out. So that's going to be backed up to a different kind of RAID, or not against RAID or anything, but you have to figure that out. That's kind of as expensive as tape now. So, but that's just remembering off the top of my head. So FTP, excellent for large files, copy multiple files at once, can resume if the connection is lost, schedule backups, and recover lost data. No security. Vendors vary widely. Not all solutions include encryption and vulnerable to attacks. So file sharing services, Dropbox, OneCloud, iCloud, etc. Quick and easy to use, inexpensive, great for collaborating and sharing data. Most file sharing services use file syncing rather than a true cloud backup. So let me bring back my controls here. On to the next slide here, and let's talk about some tools. All-in-one tools like Carbonite Safe, Carbonite Server, Acronis iDrive, CrashPlan, and SpiderOak combine both the backup software and the backend cloud storage in one offering. They can back up entire operating systems, files, images, video, and sometimes even mobile device data. Depending on the tool you choose, you may be able to back up an unlimited number of devices, or you may have limits. Just depends on how much money you want to pay. However, most of these all-in-one solutions are expensive and can be complex to use. All those bells and whistles often come at a price, and they have a steep learning curve associated with them. So let me move on here. Let's talk about integrated solutions for a second. Backup software paired with cloud storage. Pairing software and cloud storage is another option that combines the best of both worlds. It allows users to choose the software they want with the features they need and fast, reliable cloud storage. Cloud storage is scalable, remember that. So you will never run out of space using your chosen software. It's fast and easy to restore your files. Although it may seem counterintuitive, it's often more affordable to use two integrated solutions versus an all-in-one tool. Another big bonus of using cloud storage is that it integrates many popular software options. Here's a couple of examples of them on the bottom. MSP360, Veeam is the one I have heard about more and seen. I haven't used it personally. Catalogic and Arcload. So let's go on to the next slide. Creating a solid backup strategy. A solid backup strategy is the best way to protect your company against data loss. Again, you have options. The 3-2-1 strategy is the gold standard, but some companies are choosing options like 3-2-1-1-0 option or even a 4-3-2 scheme. What the hell is he talking about? On the next slide, I show you what the 3-2-1 strategy is, or 3-2-1-1 strategy. 0 strategy is. Before determining your strategy, you must consider what data you need to back up. For example, will you be backing up just servers or also workstations and dedicated servers, such as email servers or software as a service servers, data devices? God, that's a mouthful. Another concern is how you will get your data into the cloud. You need to figure out which method will work best for you. So talking about 3-2-1 strategy, the 3-2-1 backup strategy simply states that you should have 3 copies of your data, your production data, and 2 backup copies, I think of Guppies, the ice cream place, on 2 different media, disk and tape, with 1 copy offsite for disaster recovery. So here, 3 copies, 2 in storage media, 1 cloud, 1 storage media, right? 1 offsite copy, and then 1 offsite air gapped, 3-2-1-1-0. So air gapped means it's backed up, you plugged it in, you copied it over, you left it there, whatever. Air gap means there's no network connection to it, so no one can reach it virtually or through a network. They physically have to go get it. So that's pretty safe. And 0 errors at the end. So if you're curious, that's what it's like. And I will tell you now, because for those of you that do watch the lectures, hopefully it's all of you, there will be a question about this on the final. It's not that hard, I promise. Okie dokie. So here are the ones that we have built into both our Windows 10 virtual machine and our Windows Server. I was going to put the whole title up top, but it was too long, so I just called it Unit 5 Continued. So you'll see that a couple times. Don't flip out. A system restore point is a backup copy of important Windows operating system's OS files and settings that can be used to recover the system to an earlier point of time in the event of system failure or instability. Personally, I've used Windows 10 restore point at work more than I like to admit because we don't really put out the latest updates for Windows. I think we only go up to 20H2 and now they're on 22H2 off the top of my head, and it causes some instability with some of our in-house applications. So if whenever we do approve the new ones, would be like 21H2, we push it out and we notice some systems start crashing randomly here and there, and they report it back. We'll go back and restore it to prior and then tell them to, hey, block this update for now. And then that's how we use it in that sense. That's one of our first methods of recovery is we try Windows 10 restore point, but it's not loading Windows because for us, we normally push out updates on Sunday nights, and then people come in Monday morning, their machine updated, they don't know, or it's running slow, it's being weird. That's where we use Windows restore point to roll it back. Anyways, is a part of Windows XP, which is now ancient. Vista, which is even more ancient. We don't talk about Vista. 7, which wasn't too bad. 8, we don't talk about 8. It's like the redheaded stepchild. And then 10, which I still think is a fantastic operating system. And Windows 11, which is weird, but I mean, it still works. It's just a prettier Windows 10. Prettier being subjective. Sorry, I hit something back here. Let me push that back so we don't have to deal with it. Windows 11 being pretty is subjective. It's okay. It's kind of weird. So you're used to it. And Windows Server. Yeah, created automatically or manually. System restore points only affect OS and application files, but not user data. Windows Server 2016 backup utility is a feature available in Windows Server 2016 that allows administrators to back up and restore important data such as files, folders, volumes, virtual machines, and system states. Sorry. Dinner isn't agreeing with me. So that's what I have for backups and backup strategies. Let's talk about disaster and disaster recovery. So what is disaster recovery? Well, disasters and you recover from it. Pretty straightforward. It's in the name, right? But a definition is this. Disaster recovery is an organization's method of regaining access and functionality to its IT infrastructure after events like a natural disaster, cyber attack, like the one Merced had, or even business disruptions related to the COVID-19 pandemic. A variety of disaster recovery methods can be part of a disaster recovery plan. So how does disaster recovery work? Disaster recovery relies upon the replication of data and computer processing in an off-premises location not affected by the disaster. You have like a backup somewhere else, essentially. When servers go down because of a natural disaster, equipment failure, or cyber attack, a business needs to recover lost data from a second location where the data is backed up. Ideally, an organization can transfer its computer processing to that remote location as well to continue operations. Sorry. So let's go into it. So what are the top 5 elements of a disaster recovery plan? I won't make it up. You have a disaster recovery team. The assigned group of specialists will be responsible for creating, implementing, and managing the disaster recovery plan. This plan should define each team member's role and responsibilities. In the event of a disaster, the recovery team should know how to communicate with each other. You use paper and pen. Are you going to yell at each other? Are you going to text each other? What if there's no cell phones? Things like that. Employees, vendors, and customers. Risk evaluation. Assess potential hazards that put your organization at risk. Depending on the type of event, strategize what measures and resources will be needed to resume business. For example, in the event of a cyber attack, what data protection measures will the recovery team have in place to respond? Yeah, stuff like that you got to think about. It can get pretty interesting. Side note, if you guys want to make a ton of money, get into this too. I mean, cybersecurity is still going to be hot. It's not going anywhere. And AI is a new buzzword, right? But AI is not what people think it's going to be. So don't worry about that too much. Yeah, it'll be around. But here's the thing. AI is not going to take over the world for like a couple of reasons. And I'm trying to just, derail this for a second. If the computers that host the AI break down, who's going to fix them? Is the AI going to fix it? No, it'll probably be you guys or me. So, yeah. And if AI gets out of hand, we can't just sorry, go back. You can toss a cup of water at it and you fry the computer. Congratulations, you saved humanity. Anyways, moving on. Sorry, I segue out of it just to give you guys ideas. So, top 5 elements of an effective disaster plan continued. Business critical asset identification. A good disaster recovery plan includes documentation of which systems, applications, data, and other resources are most critical for business continuity, as well as necessary steps to recover data. Backups. Determine what needs backup, or to be relocated. Who should perform backups, and how backups will be implemented, including a recovery point objective, RPO, that states the frequency of backups and the recovery time objective, RTO. It defines the maximum amount of downtime allowable after disaster. Normally, the maximum is defined by the business. If it deals with import exports or Hospitals. I keep bringing up hospitals. It's the one thing I think of that's pretty critical. What's another good business? Like a furniture store, if they had stuff like this. I mean, I don't know if I see their IT infrastructure. They want to sell stuff, they can do pen and paper. And you can't take credit cards for a while, they'll take cash, but trying to think of other business off the top of my head, because I can't right now. These metrics create limits to guide the choice of IT strategy, processes, and procedures that make up an organization's disaster recovery plan. The amount of downtime an organization can handle and how frequently the organization backs up its data will inform the disaster recovery strategy. Moving on. And the fifth element, testing and optimization. The recovery team should continually test and update its strategy to address ever evolving threats and business needs, by continually ensuring that a company is ready to face the worst case scenarios in disaster situations. It can successfully navigate such challenges. In planning how to respond to a cyber attack, for example, it's important that organizations continually test and optimize their security and data protection strategies and have protective measures in place to detect potential security breaches. So here's what they look like. This is an example. This is IBM's disaster recovery. If you're curious, you can look it up online. It's 13 pages. Here are the main goals of it and the disaster recovery plan. It's all this down here. I'm not going to read them off, but this is everything it covers, essentially. That's like the main key points. And it's all in there. If you're curious, you can go through it. It's kind of dry to read. So if you're having trouble sleeping, like I do some nights, pull this up, or pull up what's the other one? One of my teachers told me ages ago. Pull up the California's guidelines for making miniature golf courses. Knock you out in 10 minutes. So how do you build a disaster recovery team? When creating a disaster recovery strategy from scratch or improving an existing plan, assembling the right collaborative team of experts is the critical first step. It starts with tapping IT specialists and other key individuals to provide leadership over the following key areas in the event of a disaster. Crisis management. The leadership role commences recovery plans, coordinates efforts throughout the recovery process, and resolves problems or delays that emerge. Business continuity. Continuity. Close enough. The expert oversees this, ensures that the recovery plan aligns with the company's business needs based on the business impact analysis, impact assessment, and recovery. The team responsible for this area of recovery has technical expertise in IT infrastructure, including servers, storage databases, and networks. That's personally where I would come in. That's more my niche versus I'm going to be in charge of the whole big picture. I don't think so. IT applications. The role monitors which application activities should be implemented based on a restorative plan. Tasks include application integrations, application settings and configurations, and data consistency. While not necessarily part of the IT department, the following roles should also be assigned to any disaster recovery plan. Executive management. The executive team will need to approve the strategy, policies, and budget related to the disaster recovery plan, plus provide input if obstacles arise. Critical business unit. A representative from each business unit will ideally provide feedback on disaster recovery plans so that their specific concerns are addressed. So, examples of disaster recovery methods. Backup. You guys know what a backup is now, right? This is the simplest type of disaster recovery, entails storing data off-site or on a removable drive. However, just backing up data provides only minimal business continuity, help as the IT infrastructure itself is not backed up. So, you could have all the data backed up and everything. It's offsite, cool. But what if your server room got flooded and that's a little bit you had servers and you didn't have anything offsite? Dead in the water. So, cold site. In this type of disaster recovery, an organization sets up a basic infrastructure in a second, rarely used facility that provides a place for employees to work after a natural disaster or fire. It can help with business continuity because business operations can continue, but it does not provide a way to protect or recover important data. So a cold site must be combined with other methods of disaster recovery. You can combine it with cloud too if you really want to for your data. That's one way they do it. And this was the most expensive one. A hot site. A hot site maintains up-to-date copies of data at all times. Hot sites are time-consuming to set up and more expensive than cold sites, but they dramatically reduce downtime. You essentially have a one-to-one copy of everything, and it's always on, so you can always reach it. So, more disaster recovery methods. Disaster recovery as a service, DRaaS. This is somewhat newer now. In the event of a disaster or ransomware attack, a DRaaS provider moves an organization's computing processing to its own cloud infrastructure, allowing a business to continue operations seamlessly from the vendor's location even if an organization's servers are down. DRaaS plans are available through either subscription or pay-per-use models. The pricing is held. There are pros and cons to choosing a local DRAS provider. Latency will be lower after transferring to DRAS servers. They are close to your organization's location, but in the event of a widespread natural disaster, a DRAS that is nearby may be affected by the same disaster. So, it's a big con. There's also a risk. Backup as a service. Similar to backing up data at a remote location with backup as a service, a third-party provider backs up the organization's data, but not its IT infrastructure. Data-centered disaster recovery. The physical elements of a data center can protect data and contribute to faster disaster recovery in certain types of disasters. For instance, fire suppression tools will help data and computer equipment survive a fire. A backup power source will help businesses sail through power outages without grinding operations to a halt. Of course, none of these physical disaster recovery tools will help in the event of a cyber attack. So, a couple more. Virtualization. You guys know what virtualization is now. Organizations can back up certain operations and data, or even a working replica of an organization's entire computing environment on offsite virtual machines that are unaffected by physical disasters. Using virtualization as part of a disaster recovery plan also allows businesses to automate some disaster recovery processes. Bringing everything back online faster, virtualization to be an effective disaster recovery tool, frequent transfer of data and workloads is essential, as is good communication within the IT team about how many virtual machines are operating within an organization. Point-in-time copies. Point-in-time copies, also known as point-in-time snapshots, make a copy of the entire database at a given time. Data can be restored from this backup, but only if the copy is stored offsite or on a virtual machine that is unaffected by the disaster. And then there's instant recovery. It's similar to point-in-time copies, except that instead of copying a database, instant recovery takes a snapshot of the entire virtual machine. So let me give it a real drink, guys. I'll be right back. Pause this. All right, guys, let's talk about virtual machine and platform service backup solutions. So what is a virtual server backup? A virtual server backup is a type of backup dedicated to protecting any data housed in virtual servers, and it is an essential part of server management. It may include anything from certain files and applications to server configurations and snapshots of the entire virtual server system. Virtual server backup is built using either a server virtualization hypervisor or an external backup application that connects with the designated storage to complete the backup. 1 second. Looks like I had a duplicate, so I just deleted that. So just covering this. So moving on. So it's 42 slides, guys, not 43. So what are the benefits of a virtual server backup? Virtual server backups are very specialized in that they only serve virtual servers. Makes sense. But there are a number of advantages to using this type of server and its associated backup type. Major benefits of using virtual server backups are virtual data protection. Virtual servers store vital information for the operation of an organization's IT environment. Data can include anything from software and system files to server configuration settings. Creating virtual server backups regularly often offers protection for this important information and ensures that organizations can easily access any essential virtual server data. Improve server reliability. Virtual server backup provides a copy of your server data in case of accidental deletion, server hardware failure, or a glitch in server software. It acts as a safety net for the data on your virtual server and ensures that the server remains functional and accessible. Your virtual server's reliability is critical for all the users and systems that depend on it. So let me segue out for a second here. It's about accidental deletion. Let me talk about this. There's a good example. I'm sure all of you, if not most of you, have seen Toy Story 2. During the creation of Toy Story 2, it was on an Apple server with Apple, because that's what they use. They use Max to generate it at Pixar. And someone deleted it by accident off of their server. They couldn't recover it. Luckily, one of, I think, the producers took a copy home, and they had it at home because they were working on it and brought it in the next day. So if you're curious about it, look it up. I'm not joking. It's actually pretty interesting how that happened. But I guarantee you after that, they started doing backups regularly. Anyways, virtual servers reliability is critical for all the users and the systems that depend on it. Lower costs. Costs of operation for a virtual server are much lower than costs for physical servers. So supporting virtual servers by backing up the data on those virtual machines helps to keep overall costs down. Whether your organization saves money in one area of IT management, it allows you to invest that money elsewhere without sacrificing overall IT efficiency. And here's some backup solutions. One's NinjaOne Data Protection. It's a cloud-first backup solution used to protect your essential data on the endpoint in your IT environment. They provide image and file and folder backup options and offer file and folder partition level, full system, bare metal restore options, all within a unified dashboard. For virtual servers, NinjaOne can take an image backup and restore it to a system where necessary. The flexibility of the backup software plus its automation abilities enable organizations to create a backup strategy that works for them. I have like 5 of them. So did I talk about data protection? Oh, I did. I guess that's a duplicate. My bad. I'll delete that one. Let me do that right now. Okay, deleted that one. You're probably seeing my bare screen right now, so let me bring that back up. There you go. Sorry about that, guys. I guess I must have missed it when I went through and pruned everything yesterday. So let's talk about Veeam backup and replication. It's another type of backup solution available for IT environments. They currently offer image level backups and can backup data on machines, whether they're virtual, cloud, or physical machines. The restore and recovery option includes image level file level restore, and more. Veeam can back up multiple kinds of devices, including physical machines, virtual machines, cloud VMs, and NAS file storage, which is pretty cool. And we have VM Backup, formerly Altaro. VM Backup is a backup solution built for protecting data on Hyper-V and VMware. It uses immutable cloud storage for ransomware protection. I forget what immutable means. I think it means it can't be reached by ransomware, something like that along those lines. To ensure that backup data cannot be changed or erased, I don't think. I think it's some kind of verification. I have to look up what it is. VM Backup also provides high functionality, with features such as duplication, continuous data protection, and centralized management of your VM backups. Unitrends Backup provides a single interface to manage a variety of backups, including virtual, cloud, software as a service, and more. This backup solution provides backup and recovery that can be managed in a single location, backup analytics, and testing to ensure that your data is protected and scalable backup software. Unithreads is a centralized backup solution used to manage complex backup environments. A couple more. Acronis Cyber Patriot is a backup software that integrates with ransomware protection to keep your data safe and secure. It provides file and disk image backup, continuous data protection, and flexible storage options. Unique features of Acronis Cyber Patriot include anti-malware scanning of your backups, a data protection map, forensic data collection, and more. Forensics is very interesting in the IT world. It's not like dusting for fingerprints. You dust for digital fingerprints with specific kinds of tools. The tools can be very pricey, but if you learn how to use them, that's a pretty interesting field to get into. Imagine trying to recover data off a computer you just picked up from some like drug dealer's house or something. You gotta scan it, and it got powered off the moment you took it. So everything that was in the RAM that it loaded got erased. Sorry, I'm going off on a tangent for a second, but that's how it would work. You would have to figure out how to recover stuff. Anyway, Nakivo Backup and Replication offers VM data protection for a wide variety of organizations like MSPs, SMBs, and enterprises. It's an HLS solution that uses one platform to manage backups and data and perform routine-based backup tasks. Nakivo also has the option to be installed on a supported machine or deployed as a virtual appliance, depending on what will work best for your organization. All right, guys, so let's get into near the tail of it here. 11 more slides. High availability in virtualization and platform service. What is high availability? High availability, or HA, is the system's capability to provide services to end users without going down for a specified period of time. High availability minimizes, or ideally eliminates, service downtime regardless of what incident the company runs into: a power outage, hardware failure, unresponsive apps, lost connection with cloud provider, etc. In IT, the term availability has two meanings: the period of time the service is available, the time the service requires to respond to a request made by a user. Jesus, I have so many duplicates. Look at that, guys. So, high availability in virtualization and platform services. High availability is vital for mission critical systems that cause lengthy service disruptions when they run into a failure. The most effective and common way to boost availability is to add redundancy to the system on every level, which includes hardware redundancy, software and app redundancy, and data redundancy. If one component goes down, e.g. one of the on-site servers or a cloud-based app that connects the system with an edge server, the entire host system must remain operational. So, avoiding service interruptions is vital for an organization. On average, a single minute of service downtime costs an enterprise $5,600. The per minute figure is in $450 to $1,000 ranges for small SMBMs. I think I put a note what it was. Oh, I didn't. I don't remember what it is. Small businesses, I think is what it is. So it is not surprising companies of all sizes invest heavily into the availability of the IT infrastructure, of their IT infrastructure. While there is overlap between the two terms, availability is not synonymous with uptime. A system may be up and running, uptime, but not available to end users, availability. Availability is also not disaster recovery, whereas HA aims to reduce or remove service downtime. The main goal of disaster recovery is to get a disrupted system back to its pre-failure state in case of an incident, which I talked about earlier. So, how high availability works. A high availability system works by having multiple hardware and software assets that needed, hence more. You have extra. So you have backups capable of taking over if something happens to the primary component. Perform regular checks to ensure that each component, both primary and the one in the reserve, work correctly. Creating an automatic failover mechanism that switches operations to a backup component is if the primary system goes down. The HA system requires a well thought out design and thorough testing. Planning requires all mission critical components, hardware, software, data, network infrastructure, etc., to meet the desired availability standard and have no single point of failure, a component that would cause the whole system to go down if it fails. Reliable, ideally automatic failover, switching from the primary component to the backup without losing data or affecting performance. Dependable failure detection, so that the system reliably identifies an issue and starts to fail over on time. And here are the benefits of high availability: minimize service downtime, improve app performance, prevent significant data loss, boost data recovery capabilities, improve brand reputation and customer experience, prevent disruptions to employee productivity, better handling planned outages. Planned outages like a patching day. So here we go. How do you measure high availability? The general way to measure availability is to calculate how much time a specific system stays fully operational during a particular period. You express this metric as a percentage and calculate with the following formula. Availability is minutes in a month minus minutes of downtimes times 100 divided by minutes in a month. So that's the formula. So how do you measure high availability? Other metrics used to measure high availability are mean time between failures, MTBF, the expected time between two system failures, mean downtime, the average time that a system stays non-operational, recovery time objective, also known as estimate time of repair, RTO, is the maximum tolerable time a system can stay down after a failure. RPO, recovery point objective, the maximum amount of data your company can tolerate losing in an incident. I mean, you can't prevent all data loss, guys. You're going to lose something eventually. Unfortunately, that's just the way it goes. So here's the outlets. How do you measure high availability continued? The most common way to measure HA is with the 5 9 availability system, in which every level guarantees somewhere between 90 and 99% uptime. The table below shows the maximum daily and yearly downtime of every grid. So there you go. Pretty interesting. I'm not going to read it all, guys. You can read it. It's not that bad. So that's essentially it, guys. So here is we covered backup strategies for users and platforms. I talked about it as a whole, just for businesses, because it applies to all of it. Disaster recovery planning and testing. I mentioned how you test. I'm not going to show you the in-depth of testing. It's just implementing it essentially in a virtual system, which I don't have a copy of to do. Virtual machine and platform service backup solutions, which I can talk about 4 of them, not 5 of them like I wanted to, because I thought I had 5. My fault. And high availability virtualization and platform services, which is the last thing we covered. So that's it for part 1 of Unit 5, guys. I will catch you in Unit 2. Till then, take it easy.